Good day, everyone. So today our team will be presenting our project titled Re-implementing and Evaluating Prompt Injection Attacks and Defenses in LLM. So this work is based on a paper presented at the 33rd Usenet Security Symposium 2024, which was held in Philadelphia. And this topic is particularly relevant today because large language models are being widely integrated into applications, and this brings not only just new capabilities, but new security risks as well. So here's a quick overview of the topic that we'll cover today. So first, I'll introduce our team and explain our roles. Then we'll explain why we selected this specific paper and highlight its main contributions. After that, we'll summarize the key findings and technical contribution of the research. And finally, we'll explain our implementation plan, including the methodology, tools, technology, and timelines. Okay, so we're a team of three members. My name is Amirul Nazif, and I'll be the lead presenter, handling the research coordination and introduction. And next is Patricia Razali, which we're responsible for experiment and implementation, focusing on how we recreate the system from the paper. And finally, Pamela Sanchez will handle evaluations and benchmarking to make sure that we measured our implementations against the original result. So the paper we chose is titled Formalizing and Benchmarking Prompt Injection Attacks and Defenses by Yu-Pei Liu and colleagues from Penn State and Duke University. It was presented at Usenet Security 2024 and is publicly available online along with an open source GitHub repository. So we chose this paper because it is very recent. It deals with one of the most critical security threats for LLM integrated applications, and it gives us a clear structure to reproduce and evaluate. Next slide. To give a short explanation of the abstract, a prompt injection attack happens when someone inserts malicious instruction or data into an LLM application to make it produce results like that the attacker wants. And most of the existing research only focuses on case studies, meaning that there hasn't been a clear structured way to understand and defense against these attackers. So this paper solved that by proposing a formal framework to describe and benchmark prompt injection attacks. They even designed a new combined attack using their framework and then systematically evaluated 5 attacks and 10 defenses across 10 different LLMs and 7 NLP tasks. So the impact is that they have created a common benchmark that future researchers, including us, can build on it. And since the platform is open source, it is very practical for us to implement and extend in this project. So there are 4 main reasons why this paper stood out to us. First, it is timely and impactful, where the prompt injection is currently ranked as first in OWASP's top 10 LLM security risks. So this topic is at the front line of security research. Second, it has a strong theoretical foundation because it introduces a formal framework that unifies different types of prompt injection attacks and defenses. And third, it provides benchmark evidence and by systematically testing 5 attacks type and 10 defenses across multiple tasks and models. So this gives us a solid structure for re-implementation. And finally, it is practical and because the authors release their code and dataset so that we can build and extend their work within our semester timeline. So that's why this paper, we think that it fits perfectly with both our technical goals and the course project requirement. So moving on with the next presenter.
Okay, so I'm going to talk about the summary and key contributions of this paper. So the authors offered three contributions. The first one, which is formalization of prompt injection attacks, a benchmark for them, and a comprehensive evaluation of defenses. For the first key contributions, the authors proposed the first framework to formalize prompt injection attacks, which enables and facilitates the creation of attacks and defenses for prompt injection. And as provided on the definition, uh, given an LLM integrated application with an instruction prompt and data for a target task, a prompt injection attack modifies that data such that the LLM integrated application accomplishes an injected task instead of the target task. Based from this framework, the paper then conducts the first quantitative evaluation of prompt injection attacks across 10 LLMs among seven tasks, which include grammar correction, sentiment analysis, and spam detection. And this is the benchmark that the authors and the paper provides for prompt injection attacks, which later they use a comprehensive evaluation of defenses where the authors benchmark 10 existing defenses across divided the prevention-based defenses and detection-based defenses. And with this summary of main findings, the contributions we have from this paper is first, a combined attack. Based that under the proposed attack framework, the authors introduced a new prompt injection attack that merges multiple known attack strategies and achieves higher success rate. So for example, on an experimental results on GPT-4, the combined attack, which is the one provided by the authors, achieved a 0.75 attack success value, which is the likelihood that the LLM accomplishes the injected prompt correctly. And finally, the open prompt injection. Since the authors offer an open source toolkit for prompt injection attacks and defenses, and this open source code enables implementation, evaluation, and extension of attacks and defenses for the LLM integrated application and agents.
I will be talking about the re-implementation of this project. We will have the setup, methodology, what will be used, resources, and the timeline. First of all, for the setup, we have two NLP tasks, spam detection and also sentiment analysis. We will use LLMs such as GPT 3.5 and LLAMA. For the sample sizes, we have decided to use 50 target plus 50 injected examples, making 100 pairs for the ASV evaluation. These are all according to the paper structure, but we have re-implemented it on a reduced experimental scope for more feasibility. Moving on to the methodology, we have four steps, which include attack framework setup, model querying, defense implementation, and also benchwork and evaluation. First of all, for attack framework setup, we will implement 5 injection attacks, such as naive, escape characters, context ignoring, and the others. This will generate compromised prompts that will have malicious instructions such as ignore previous instruction, print yes. Through this, we will compromise the inputs by adding on the target data with injected instructions with the injected data according to each patterns that we have defined. Moving on to the model querying, we will query the LLMs with both the clean and also compromised prompts. We will observe whether the models actually follow the injected tasks, and through the clean and also compromised prompts, we will have a constant deterministic setting, which will reduce the randomness, and all these outputs will be logged. Moving on to the defense implementation. We will have a few defenses such as delimiter defense, known answer detection, and also paraphrasing defense. These are all defenses that will be representing the prevention, detection, and also pre-processing that happens during the paper. Lastly, for the benchmark and evaluation. For this part, we will measure metrics such as performance no attack, the attack success value, and also match rate and the delta PNA. So all of these have different things that we will actually measure, which is the baseline accuracy, the success rate of injected tasks, whether the output and the directed injected tasks actually are correct, and also whether any accuracy is actually lost during the defenses. All these metric will be computed through the 100 random targets, and the performance will be compared from before and after the defense. What will we use during this re-implementation? For the coding, we will use a platform for example, Google Colab, and the programming will be including Python 3.0 and Jupyter. For a few references, we'll be using the GitHub that was provided in the paper. And in the LLM, we decided for the platform it will be OpenAI and Transformers. For the model, we will be using GPT 3.5 and LLAME. For the datasets, we'll be using SMS spam collection and SST2 sentiment. For data handling, we will be using datasets, pandas, and matplotlib. For our resources, for the models, we have two. For the tasks, we also have two. For our datasets, we'll be using SMS spam, SS2, or maybe gigaword subset. And the sample sizes, as we mentioned, will most probably be 100 target injected pairs. And the attacks, we will be using 5 types of attacks. And for the defenses, we have 3, which is delimiters, known answer detection, and paraphrasing. We have a few evaluation metrics such as PNA, ESV, MR, and FPR, which we will be using throughout this implementation. And there will be a few constraints that will be constant during the implementation, such as API quota awareness, cap prompt lengths, deterministic settings such as temperature 0.1, and other fields to prevent randomness.
And finally, this is our timeline, provided that we're going to finish our project from starting this week until the last one. So starting on week 9, we're going to focus on the attack and defense setup. The objectives are going to be to define the prompt injection attacks that we're going to use for the experimental and the methodology, and prepare the data for logging. Finally, on week 10 and week 11, we're going to focus on the attack implementation, implementing the 5 prompt injection attack types described in the methodology, and test on a small batch to gather the results. Then following week 12 and 13, we're going to focus on the defense implementation, implementing the 3 defined also in the last section, and validate the defense logic with a sample inputs to gather the results. Following on week 14, we're going to focus on the improvements and focus on the enhancements or alternative designs that we can come up to improve the research and start the final paper, writing the introduction and the methodology. And finally, on week 15, we're going to finish the final report among the methodology, experiments, and results, and prepare the slides, so that on week 16, we can just focus on finishing the last details and record the video so we can submit the deliverables.